Number 7 on the vector and 1D motion part of the performance funnel. This is similar to number 6, and it is two separate problems that are just next to each other. So I've got a race car that's going to accelerate uniformly at a rate of 11.2 meters per second squared. I know for sure that that's my acceleration just because of meters per second squared. It starts at some unknown initial velocity and goes up to 46.1 in 2.47. So the first part just says, what is the initial velocity? It's a separate, pretty easy problem. He starts off with some unknown velocity, and over the course of 2.47 seconds, he reaches a final velocity of 46.1. And I also know that the acceleration during this point is 11.2 meters per second squared. So I can do part A to start off with, real easy. What is the initial velocity? Out of the colored equations, you can pick the pink one or the blue one. They're the same equation, just rearranged. The blue one is easiest, I think, for this, but it doesn't matter as long as you do it correctly. You'll get the same answer both times. So I've got 46.1 equals my unknown plus 11.2 times 2.47 seconds. Then my calculator. I have 46.1 BI plus 27.664. I subtract that from both sides. And find that the initial velocity for this section is 18.44 meters per second. So that's the part, that right there is your answer to part A. Okay, then for part B, I'm adding on a second problem. I want to know, okay, now after that acceleration portion, the car continues for another 4 seconds. I want to know what's the total displacement from the beginning of that very beginning here where it started off the accelerating part and the 4 seconds afterwards. So again, you're never going to use 6.47 seconds as your T for anything. It's two separate problems that are right up next to each other. So it's a lot like number 6. All right, so for the second half, this is a constant velocity problem, which, what is the constant velocity then? It's going to be whatever. So I started off slow and I got faster and faster up till 46.1. So the constant velocity for this part is 46.1. That's how fast he's going to continue through this. The time for this constant velocity portion is the extra 4 seconds. Notice I'm not ever going to use that 6.47. And I'm going to try and find the distance here and the distance here and add the two together. Again, the only equation I can use for constant velocity is d over t. So I'll have 46.1 is equal to the displacement over 4. So the distance gone in this second section here is 184.4 meters. So that's part of what I need. That's how far he went just while he was coasting along. I also need to know the distance over here. And there's lots of different equations that you can use to find it because you do know the VI now, but you also have A and T and VF. There's lots of different ones that you could use. I'm going to go ahead and use the yellow equation because it's easy and set up. Actually, I'm going to use the red equation instead. So D equals VF plus VI over 2 times T. So 46.1 plus 18.4 all divided by 2 together and then multiply by 2.47. And you can put it, if I do that all on my calculator, you want to make sure that you've got parentheses around the entire top. So I've got 46.1 plus 2.44 divided by 2 times 2.47. So the distance in this part. So it's really just two separate questions that are just being put together. So the total distance is going to be this 179.7 plus the 84.4, and the total is 260. That's the answer to part B.